Hello, in this video I'm going to solve question 3, problems set to lecture 3, lectures in elementary number theory. Determine all natural numbers n for which the fraction 5 plus n all over 7 minus n is a natural number. Pause the video at this point and give it a try. Okay, to solve this problem, I want to choose all possible values for n, natural numbers n, so that 5 plus n divided by 7 minus n becomes a natural number. Okay, so first let me concentrate on integers, and I want to make this as an integer first. Okay, so this becomes an integer if the numerator is divisible by the denominator. So in other words, 7 minus n should divide 5 plus n, okay? And I want to find n. My goal is to make this a constant, okay? Because if that's a constant, any number, then this means this will be a factor of that constant. Then it is very easy to see which numbers 7 minus n can be if I can manage to make the right-hand side a constant. And I want to use this theorem that I covered in lecture 3 on this playlist, elementary number theory playlist. So we learned there that if an integer, divides another integer, then if m is also an integer, you can keep the left-hand side and add this multiple of a to the right-hand side. So in other words, if I have a divisibility relation, if I want to, I can add any integer multiple of the left-hand side to the right-hand side. It will generate a new divisibility relation. If this is true, this one will also be true. And we also show that the other way around is also correct. So in other words, if an integer multiple of the left-hand side appears as a summand on the right-hand side, if I want to, I can eliminate that. And if this one is true, this one will also be true. So these two statements are equivalent. Okay, so now what I want to do, I want to give the role of A to 7 minus n, and I want to give the role of B to 5 plus n, and I want to give the role of m to the integer number 1. Why 1? Because if I add 1 times of this to the right-hand side, this minus n will cancel that n, and I will have my constant that I need. So what I will do, from here, I conclude that I copy and paste the left-hand side, 7 minus n, divides, and then I have 5 plus n plus 1 times of this expression to the right-hand side. So if you compare this one, you can see that 7 minus n is just my capital A, and capital B is this expression, and m is 1, and A is this expression. Okay, so let me simplify that. So from here, I can conclude that 7 minus n divides, if you multiply this, 7 minus n added here, n's are gone, so 7 plus 5 is 12. Okay, but what happens? 7 minus n is supposed to be a factor of 12. So it means that this part happens if and only if 7 minus n is either minus 1 or 1, minus 2 or 2, minus 3 or 3, minus 4 or 4, minus 6 or 6, and finally minus 12 or 12. So these are the only possibilities, yes? If 12 is supposed to be divisible by an integer, that integer can have these possibilities, okay? But I am looking for n. So this is if and only if, yes? If 7 minus n is one of these numbers in this list, this is valid. And if this is valid, 7 minus n is one of the numbers in this list. So these two are equivalent. Of course, between all of them, I have to put the or, okay? So now let us calculate n. Okay, so if 7 minus n is minus 1, so let me write the list of numbers for n. So using this, I can find that n is 8, and then using this, I can find that n is 6. Using that, I can find that n is 9. Using this, I can find that n is 5. Yes, this one and that one gives me n to be 10. This one and that one gives me n to be 4. And then this one with that one, n will be 11. This one with that one, n will be 3. This one with that one, n is 13. This with that, n is 1. And this finally with that one, n is 19. And this with that one, n is what? N is minus 5. Okay, so these are the possible values for n. But of course here they don't want us to have integer values. They want us to have natural numbers. But before going to that step, let me keep this as z for the time being. In principle, you have to be careful. My goal was to find integers for which this is correct, but instead I found integers for which this is correct. Okay. But the point is that this statement and that statement are equivalent. Why? Because if this is the case, so first of all, you see that this and that are equivalent. So there is no difference between them mathematically. But this one, because this arrow can go in that way, you see that from here I can go there. This is simple. 7 minus n is just 7 minus n. Of course, 12 can be written in this form as well. So that I can go backward here, that is okay. But from here, I can also go backward because of this arrow in the left side also works. So this means that mathematically speaking, this statement that I was willing to solve and find the ends for them, and this final statement are equivalent. So this means that I am not worried. All these answers that I got here, I know that makes this statement, they make this statement true, and this statement is equivalent to this one, so I don't need to be worried. All these numbers I got here will make this one also true, and I will not have more than these numbers, okay? So if one of these arrows are not reversible, is not irreversible, then I have to really be careful. These will be candidates for this, candidate solutions for this. Okay, I have to check them one by one, which one or which ones are false roots or false solutions. Okay, but here I don't need to be worried. All of them are acceptable because these two statements are equivalent. Now the only thing that matters is that they are not asking you to find all integers. They are asking you to find all natural numbers. So I have to drop this from my list. The second thing is that they are asking you that this expression should be a natural number, not an integer. So I have to be careful about that. So this, so far, I guaranteed that this is an integer. But to make this integer a natural number, this should be also positive. So this means that numerator and denominator should be simultaneously positive or simultaneously negative. So then I have to be careful. N equals to 8 will work. No, it will not work, you see, because the numerator becomes 13, the denominator becomes minus 1, so it becomes negative. This is why I will take this out from my list. What about 9? The 9, the same. What about 10? The same. So these are cancelled. What about 11? That is also cancelled. 13, 19, these are cancelled. But 6 is acceptable. 5 is acceptable. 4 is acceptable. 3 is acceptable. And 1 is acceptable. Of course, if you want to be on the safe side, you can test them. For example, if I choose 6, 5 plus 6 is 12. And then 7 minus 6 is 1. So that's correct. If I choose 5, the numerator becomes 10, the denominator becomes 2, which is 5. That's correct. And you can check for 4, it's 9 over 3, that's correct. For 3, it's 8 over 4, that's 2 correct. And for n equals to 1 is 6 over 6, which is 1, it's also correct. Of course, we knew it should be correct because I know that these two statements are equivalent. So the answer to this problem is just 1, 3, 4, 5, and 6. Okay, I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.